Hello everyone, welcome to the study of this chapter. In this chapter, we will learn the relevant content of the backend. This is a very important chapter for us to use high code, ranging from our registration system to the OA and trading platform, which cannot be separated from our reasonable backend architecture and use methods. Of course, backend-related learning is not overnight, there is a long-lasting charm in it. In this chapter, we can learn the general methods of basic operation and database architecture, but how to carry out more reasonable database and service design requires a lot of knowledge accumulation. After all, we can only visualize the data architecture without us writing code, but this does not mean that you do not need to master that knowledge. Let's start with the first section. The introduction to database mainly includes the following contents. First, we'll talk about the definition of database, then we'll talk about how to add a database to HeCode, and finally we'll introduce the classification of database. First, let's come to our data. The definition of the database is that the database is the basic widget to save an application data. The data is essentially a data management software. We can understand it as an advanced Excel table. Most of the databases are installed on the remote server, which is used to store application backend data and provide the client with an access. Generally speaking, we need Hakubo. The remaining data needs to be stored in our database, and then the data we store in frontend is quite different. Then we take a look at the method of adding the database. The method of adding the database is very simple. Select backend in our object book and click it to complete the addition of the corresponding database. Here we open the editor to do a simple demonstration for you. First of all, we open our editor, input the database in the application name, and then click Create, so we complete the creation of the application. This time, we don't have to form a good habit, because the things we want to add are in the backend. We select the backend, and we will know through the previous study HeCode is separated from the front end and the back end, so front end and back end contain different sets of widget, and the database is located in the widget set of our backend. Here, let's select the backend, and you can see that this series is actually our database. We can add a pair of databases with a click. Similarly, we should form a good habit. After adding any database, we double-click it to rename it. For example, this is our case database. Then we will talk about the classification of databases. There are many methods for database classification. First, let's classify it according to the type of database. It mainly includes the following points. First, let's one is our relational database. What is our relational database? Relational database refers to a database that uses a relational model to organize data. It stores data in the form of rows and columns so that users can understand the relational database. This series of rows and columns are called tables, and a group of tables form a relational database. Users retrieve the data in the database through query, and query is an executive code used to limit some areas in the database. The relational model can be simply understood as a two-dimensional table model, and a relational database is a data organization composed of two-dimensional tables and their relationships. For example, MySQL, Oracle, and so on are our relational databases. The second is our key-value storage. The key-value database can be used to add queries or delete databases. Due to the use of primary key access, its performance is highly scalable. The key-value database mainly uses a hash table, in which there is a specific key and a pointer to specific data. The key-value model has the advantages of simple, easy to deploy, and high concurrency for IT systems. For example, Memcached, Redis and MemcacheDB are all our key-value storage databases. The next is our document database. The document database can be regarded as an upgraded version of the key-value database, which allows the nesting of key values. The query efficiency of the document database is higher than that of the key-value database. The document-oriented database will store the data in the form of documents. Each document is a self-contained data unit, and a collection of a series of data items have a noun corresponding to them. Values can be simple data types, such as our string, number and date, or complex types, such as ordered table and associated object. The smallest unit of data storage is the document. The document property stored in the same table can be different. Data can be stored in XML, JSON, and other storage formats. For example, our MongoDB, CouchDB, and so on are all our document databases. Then there is our column storage database. The column storage database stores the database in a column family. A column family storage is often used to query relevant data together. For example, our human beings often query a person's name and age rather than his salary. In this case, we will put his name and age in the same column family, and put his salary in the same column family in another column family. This kind of database usually corresponds to the massive data stored in distributed storage. For example, our HBase is our column storage database, and finally our graphics database. The graphics database allows us to store the data in the form of graph. The entity will be regarded as a vertex, and the relationship between entities will be regarded as an edge. For example, our Neo4j and Infor-Grid are both our graphical database. The database we use most in HCode is our traditional MySQL relational database. When we create a database, it corresponds to a MySQL table in the backend. Through access restrictions in our HCode, we can also divide the database into an application database and an account or our enterprise database. If you add an enterprise database here, you can click our backend resources with the backend selected. Under different classifications, you can see that some enterprise databases you share throughout the enterprise can be added here. For example, if I click here, I can connect an official website to such an enterprise database and add it to an application like me for use. In our HCode, we can also classify the database by feature, which can be divided into our ordinary database and our special feature database. So first, let's talk about our common database. What is our common database? Ordinary database is the purest relational database without any operation, that is, our MySQL database. It does not have any preset actions, and any field and service definitions need to be completed by ourselves. And our so-called ordinary database corresponds to, when we select the backend, the private database here, and our enterprise database here. These two are our most pure MySQL database. When you click it, you can add it, and the common operation of the database we will explain in the next section. In addition, we have designed a series of special feature databases for you in HCode, and the so-called special feature database may be our relational database. We have carried out some basic encapsulation on it to encapsulate some actions and events, so that you can easily use some of our specific functions in certain specific scenarios. First of all, the first one is our user database. The user database corresponds to the user database when we select frontend as our user database. Similarly, we can click it to add it to our backend. For the user database, it is mainly used to make the basic user login in the application, register users, manage and use the setting of the user permission function is essentially a user data table, but it contains some special functions. We encapsulate them for you. For example, when you initiate login, we can help you record some information of the user and help you keep the login status of the user. In addition, you can also obtain some information of the user and initiate mobile email registration action and reset a password through our mobile email. Of course, you can also exit its login status, and you can also control the user access rights. In our user database, we have set some basic fields for you. Through the use of these basic fields, you can easily log in and log out some users' feature. For all our special feature databases, here we only give a brief introduction. In the future, we will set up a special topic to explain each special feature database in detail. The next special feature database is our voting database. Similarly, when we select Backend, we can see that there is an icon here, which looks like a sign of a ticket put into the mailbox. This is our voting database. As far as our voting database is concerned, it is a backend widget dedicated to the voting function. Its essence is that we internally help you to establish two related database tables and encapsulate a series of actions. For example, when you choose a voter to vote, we will automatically help you to record his voting flow and will put the candidates in the add one to the corresponding number of votes. So using our voting database, we can quickly build a voting type of application, and the next special feature database is our e-commerce database. According to the actual interaction behavior of users, the e-commerce database provides a series of operations including obtaining goods, commodity architecture, submitting orders, generating orders, and paying orders. Generally speaking, it can quickly help us manage a commodity and quickly build an electronic mall. It comes with 3 databases, including our commodity database, shopping cart database, and commodity order database. Generally speaking, it will realize our commodity and order management. In fact, the main reason is that we have given you a special commodity database, which provides various fields required for the basic commodities, including commodity specification inventory, etc. Once the order is submitted successfully, our commodity inventory will be updated automatically, and the total price of commodities will be calculated automatically, which provides a basis for subsequent payment stable and reliable information. In addition, it also provides an online payment function. The payment of our e-commerce widget mainly relies on our Wechat payment. After the order is generated, the payment information is automatically generated. The backend of Wechat payment is supported by Tencent's big data, which ensures the security of user transactions to the maximum extent, provides security protection for users, and realizes the payment function. Only the corresponding public data needs to be configured. Numerous numbers and merchant information have greatly improved our development efficiency. Of course, I would like to remind you that for our e-commerce database, we must use it together with a user database. Based on any shopping cart behavior, including our purchase behavior, we must come from a logged-in user. For our e-commerce database, it is convenient for us to quickly build our WEB or email of small program, or develop online booking service and realize the function of online payment. Further down is our routing table widget. For this is a big disk here. This is our routing table. The main purpose of widget routing table is to do our SEO and optimize our search engine. When we finish a content, we hope that the search engine can include our content and can directly search our web pages on Baidu or various search engines. Then we need to use our SEO, that is, a routing table such as our search engine optimization. It is precisely because of such a series of property, our web source code can support our SEO, so if we need a search engine to be able to search our web content, we need to use our routing table. Next is our Yes database, which is a special distributed database for full-text search. It is also the most widely used database software in the same kind of database on the market. Its main function is to segment and index our data. When the user enters a query statement, the query statement is segmented and combined with the existing number according to the segmentation of the database. A matching query is carried out, and the data records with the highest matching degree are returned. Therefore, different from the ordinary MySQL database, we can use the ES database to realize the functions of full-text search, fuzzy query, and so on. ES word segmentation index and distributed computing structure can return users' queries very quickly, instead of using such inefficient data to facilitate queries like ordinary MySQL databases. Next is our fast table, which is a distributed non-relational database. Its main function is large-scale data reading and writing. It can be used as a business scenario of high concurrency and big data, such as the implementation of large-scale online business of the Internet of Things. Further down is our DBO. DBO is a tool for connecting custom databases in HiCode. At present, through our DBO widget, we can connect to any MySQL, Oracle, SQL that we have deployed server, and PostgreSQL databases. We can directly write our own SQL in the service logic of X to operate our database, obtain the returned results, and connect seamlessly with other service logic. In other words, through the DBO widget, we can directly connect to the database in use to achieve a data direct connection function. Then we will introduce a series of feature points for you. These feature points are all some widget of the backend, and we also attach a relational database as a record of the use of feature points. The first is our Wechat Red Envelope. Wechat Red Envelope can issue a cash red envelope to our Wechat users. After receiving the red envelope, the funds will automatically reach the user's Wechat payment change account, which has the same use export as other funds in the Zero wallet. If the user does not receive it, the funds will be returned to the WeChat payment account of the merchant 24 hours later. Generally speaking, when we do marketing interaction, we often use such a widget and then a payment point. We can think of the payment point as a simple version of e-commerce widget. After it is configured, we can call our WeChat payment. For the content after payment, we can judge whether it has been paid by the order number, so as to achieve a similar payment pay for online trading scenarios with alcohol. The payment point does not have the commodity order and shopping cart in the e-commerce widget. It is more like a one-time payment operation for a certain service. Generally speaking, as long as we are not engaged in e-commerce, we can use our payment points to meet the demand for paid services. And if your ability is high, we highly recommend you to build an e-commerce database by yourself and make a payment through our payment point instead of using our ready-made e-commerce widget. Because our ready-made e-commerce widget has a lot of functions, we have helped you limit it. If you want to do some flexible expansion, you will be relatively more flexible than more difficult. Then there is our SMS widget. After adding our SMS widget in the application backend, we can use our SMS widget to send SMS messages. Generally speaking, we will record the successful SMS messages in the SMS data table and deduct the corresponding fees according to the standard of 10 FN each. As a result of SMS widget, he brought a relational database, so it is convenient for us to query whether some SMS content has been sent. Then down is our mail widget. The mail widget is a backend widget in our HiCode. After we add this widget, we can achieve a function of sending mail to the specified mailbox. When we finish sending and receiving an email, we will store the submitted user, recipient, title, content, etc. in our database. The above is about the backend database and special feature point of a brief introduction. Thank you for watching.